Okay, so now we are continuing the exam review. We are starting at number 54. 54 says use a table of values to graph each function. We actually didn't learn it that way, so I'm going to have you do it the way we learned it to find the domain and range. Okay, so when we look at this, we're going to look for axis of symmetry, which we abbreviated AOS. And to find the axis of symmetry, it's negative b over 2a. We're going to find the vertex. To find the vertex, this equals x, so we're going to plug in this value. So plug in x for y to find y. And then the last part was the y-intercept. And the y-intercept is 0c. Okay, so this is already in standard form for us, which is nice. So a is going to be 1, b is going to be negative 6, and c is going to be 3. We're going to find these things so that way we can graph it and then determine the domain and range. Okay, so AOS is going to be negative 6 over 2 times 1. 6 over 2 equals 3. So that's our axis of symmetry. Now we're going to take this, so x equals 3. We're going to take this and plug it in. So this would be negative 6. So y equals negative 6. So we have these coordinates here of 3, negative 6. This is our vertex. And then last but not least, y-intercept. Y-intercept is 0c, so that's going to be 0, 3. Okay, so we're going to use this information to actually graph this so then we can determine the domain and range. So here is our graph. Okay, vertex is at 3, negative 6. And 1, 2, 3, 4, 5, 6, so about right here. Axis of symmetry is at x equals 3 right here. It says we have a y-intercept at 0, 3. Okay, so our graph is going to go up like this. This point gets reflected on the other side, and here's what our graph looks like. Now that we have this sketched out, we can find our domain and range. Domain is all the x values, so our domain is going to be negative infinity to infinity, or all real numbers. And then our range is our y values. The lowest y value is going to be negative 6, and then it goes up forever, so to infinity and beyond. So domain, infinity to infinity, how that might look on the test is all real numbers. And then this could also be formatted as y is greater than or equal to negative 6. Okay, number 55, same type of problem. Now it's asking for us specifically to find the vertex, axis of symmetry, and y-intercept. I have these notes up here. If you want to add more notes on your paper from that lesson, you can. But let's see. We're going to start with axis of symmetry. AOS is negative b over 2a. So negative 8 over 2 times negative 2. 2. So x equals 2. That's my axis of symmetry. Then to find the vertex, I'm going to plug that in. Y equals negative 2. Have that. So I have 8 minus 5, so that's 3. So y equals 3. Okay, so why did I write 3 twice? I don't know. Okay, y equals 3. So our coordinates here for the vertex are going to be 2, 3. That's the vertex. Vertex. Axis of symmetry, AOS is x equals 2. And then last but not least, we need the y-intercept, which is 0c. So 0, negative 5 is our y-intercept. Okay, and that's what we'd be looking for in the answer choices. Next, which equation corresponds to the graph below? Okay, so x-axis, y-axis, we do have a quadratic. It looks like it's down at negative 1. If you remember the translation rules, the vertical change is actually this last number. So it's actually this right here. It's going to be c. x squared is positive going up. The negative x squared would mean that the quadratic's going down, and that's not happening. And then this is our vertical change, so it's going down 1. Okay, next, 57. Find the equation of the axis of symmetry and the coordinates of the vertex of the graph right here. So same idea. AOS is x equals negative b over 2a. So negative 12 over 2 times 2. 12 over 4 is 3. So axis of symmetry is x equals 3. And now it wants the vertex, so I plug this in. And this all adds up to negative 12. So y equals negative 12. So we have our axis of symmetry is x equals 3, and then our vertex is at 3, negative 12. Okay, next one. Write a quadratic equation in standard form with these given roots, 7 and 2. So the equation for this was x minus p, x minus q. So we're just going to plug these in here, x minus 7, x minus 2, and then we need to FOIL it out. So x times x is x squared, outside negative 2x, inside negative 7x, and the last one's positive 14, and just simplify. Minus 9x plus 14. And that's what you'd be looking for in the answer choices. 59, solve each equation by factoring. Okay, so we're going to factor both of these out, starting with the first one. Two numbers that multiply to this and add to this. So that would be negative 6 and 2. These are two numbers that would add to negative 4 and multiply to negative 12. And then once we get this far, we need to set each of these equal to 0. And solve. X equals 6 and x equals 2. So my solution set is this. Sorry. Oh, this should be positive 2. Sorry, that's an error. Okay. This is our answer. Okay, and 60. For 60, I noticed that I have a common factor in all the terms, which is 5. So I'm going to start by taking that 5 out. Okay, and now I can factor this here. And the 5 kind of goes away, because if you were to divide both sides by 5, it would just cancel. So we can just factor this at this point. Two numbers that multiply to this and add to this would be negative 3 and negative 4. Negative 3, negative 4 would multiply to this and add to this. So x minus 3, x minus 4 equals 0. Set each of these equal to 0 and solve. We're done. Okay, 61, solve each equation by using the quadratic formula. I'm going to write down the quadratic formula here. Negative b plus or minus square root of b squared minus 4ac over 2a. So we need to just plug the numbers into here. We need to have this in standard form first, though. This needs to be equal to 0. So we're just going to subtract 3 from both sides to get it equal to 0. 3x squared plus 8x minus 3 equals 0. Okay, now I can plug in numbers. Okay, once I have everything plugged in, I'm going to solve using order of operations. Negative 12 times negative 3 is going to be positive 36. Just moving up here. Square root of 100 over 6. So square root of 100 is going to be 10. I'm going to write this out two ways, one with plus 10 and one with minus 10. Plus 10 over 6 and negative 8 minus 10 over 6. 2/6 and negative 3. So I got 1/3 and negative 3, and that is my answer. 62. Solve each equation by using a square root property, round to the nearest hundredth. So right here, I'm going to come up with two factors here, which would be x plus 4. X plus 4 equals 1. That would be x plus 4 squared equals 1. Take the square root of both sides, and this becomes plus or minus square root of 1. So x plus 4 equals plus 1 or positive 1. And then x plus 4 equals negative 1. X equals negative 5. So the way it might be written is like this. Next one, same process. Two factors here, x minus 7, x minus 7. So that would be square root of x minus 7 squared equals plus or minus square root of 9, which is square root of 9 is 3. Positive 3, x minus 7 is negative 3. So I get 4 and 10. Okay. And last but not least, oh, how did I get, yeah, okay, we're good. Okay, last but not least, this one right here is a pretty simple question. For whatever reason, this one isn't the most simple because we're dealing with some fractions here. To find c, the equation is b over 2 squared. So we're just going to take b, 11 over 2 squared, and if I were to plug this into the calculator, I would get a number that's like 30.25. But they actually have us working with fractions in this. So 11 over 2 squared times 11 over 2 squared would be 121 over 4, and they actually use this. So c is 121 over 4. And then to factor this out, x squared plus, or not x squared plus, sorry, factors would look like this, x plus and x plus. The two factors that would multiply to 121 over 4 are 11 halves and 11 halves. So that is actually what they're looking for, or x plus 11 over 2 squared would also be correct. Okay, so that is for the exam review. I will grade this on Monday, so just hold on to it. Make sure that you're looking over it and studying it over the weekend. If you want to print it out again and complete it again, it is available on Schoology for you to print. But have a good weekend, and I'll see you on Monday.